Okay, let's solve this question. The question states that consider the following three functions. These are the three functions provided to us. Okay. Which one of the following options arrange the functions in the increasing order of asymptotic growth rate? What is asymptotic growth rate? I would like to revise you on that. That big O notation, big theta notation, big omega notation, and all the simplification in terms of expressions that we had done. These expressions by themselves are called asymptotic expressions, right? These are asymptotic expressions, right? They are nomenclature. The thing that they are called with is asymptotic notations. So we have to consider them from asymptotic notations and how their growth rate is being affected, and we have to arrange them in increasing order. That is the intent of the question, and they want to ask us the order in which these three functions will be arranged. Now, first of all, let me revise you what kind of simplification is allowed under big O notation. Suppose there is some kind of expression over here. Let's say a polynomial expression of something, x square is present, and there is a coefficient added over here. This coefficient can be dropped, removed under big O notation, and it is not going to affect. It's a simplification regarding growth rate, so it can be dropped. Likewise, if suppose there is some kind of expression added over here which we know to have a lower growth rate compared to x square, suppose for example x 7x, right? This 7x plus 9, so this is going to have a lower growth rate compared to x square. We can directly drop this, remove this. That is something which big O notation provides us with in terms of simplification rules, right? So these three functions that are provided to us, their simplification done under big O notation rules does not yield us anything, because these two simplification criteria kind of expressions are not present in any one of these threes, right? So now the student is going to be confused. They are going to say that asymptotic growth rate is to be considered, and that is not applied over here, applying over here directly, right? So for that, once that big O notation is not usable, now you have to apply general mathematics concept to solve this. And there is a concept of mathematics 11th 12th concept. I would like to revise you on this. Suppose that there is a function g that is an always increasing function, right? Always increasing function. So this always increasing function is going to give if f1 and f2, suppose for instance, I'm not saying that they are, but let's suppose that f1 is greater than f2, or it's suppose that f1 is less than f2. Both of them being true, if g is an always increasing function, right? G is suppose like this, always increasing, right? So we can apply g on both sides of this, and still the inequality is going to hold. That is a property of mathematics. And why is that a property? I'm going to give a demonstration of that also, because let's say this is a, this is b, right? So this corresponds to g of a. Likewise, this corresponds to g of b, right? Because in this distance from a to b, because b is greater than a, and this distance from a to b is going to cause g to increase, right? So from, if b is greater than a, this implies that g of b is also going to be greater than g of a, right? This is the in general property of mathematics, that if g is an always increasing function, then its application to any inequality does not change the inequality. The resulting inequality also holds, right? Whatever be the distinct arrangement of this, we can apply an always increasing function over here to simplify it, right? And once that part is very clear to you, something else must also come to your mind. These three expressions, the complexity of these three expressions come from the fact that the n over here is raised to the power of log n, right? N is coming in the exponent part of the expression. That is the complexity introducing portion in this, right? So if we can take this exponent part and bring it down, it is going to immensely simplify the discussion, right? And what is the function which has this property of taking down the exponent and bringing it down to our level, normal level? Well, now what else but log? Log has a always increasing function. This is a log, right? So if I apply log on this, every single one of these expression, all the inequalities, whatever expression we get from that is going to also hold for the original ones, right? So let's apply that log over here. So it is going to give us n log 10 log n log n root n log n. Simplifying further, n log 10 log n square and root n log n. Over here, this and this may have some ambiguity to it, because this 10 is a constant, okay, this n and this root n times log n, we don't really know, right? But this log n square is going to be less than this one, because root of n has a greater growth rate than log of n. Likewise, n has a greater growth rate than log of n, right? So this f2 is going to be f2 representing, this is not exact f2, but the f2 that this corresponds to is going to have the least growth rate, right? That part we know. So which one of them have f2 in the first portion? First, because it is an increasing order, right? So the first function is going to be the lowest growth rate function, right? So f2 is present in both of these, so answer is going to be one of these, and a and c is not going to be possible, right? After that, what we have to do, we have to compare this thing and this thing and find which one is greater. Directly we cannot really do it very clearly, so we already have a function that can simplify this raised to the power conflict. This raised to power 1 by 2 is the complex part over here, right? So apply log to this whole thing one more time. Always increasing function, right? Its application is not going to affect the inequality status of these two expressions, right? So inequality representation is not going to flip or do anything, right? So n log 10, let's write it one more time clearly, log n whole log is going to give us n log n plus log 10. Likewise, it is going to give us 1 by 2 log n plus log n, right? So this log n is very small in comparison to simple log n, right? So this is not going to impact that much. Likewise, this is not going to impact that much, right? This is a constant, furthermore to say, right? While this log n and this log n, this 1 by 2 is present over here. Now some of the experts, right, some of the overconfident people who have studied big O notation are going to say that this kind of expression can be simplified directly by big O rules. No, it cannot be, because this 1 by 2 is not present in the original function, right? If original function it were to be present, then big O notation can simplify, but after applying 2 times log, this 1 by 2, so this cannot be simplified in that fashion, right? It has a lot more significance. So from the significance of this 1 by 2, after the application of log 2 times, we can say that yes, the f1 is going to have a greater magnitude than f3. Very good. And we know that f2 is the least one of them all. So basically giving us the answer that f2 is less than f3 is less than f1. That is the whole of the question. Not very difficult, but obviously requiring a bit of mathematical rigor, practice. Right? Which one of them? F2, F3, F1. So D is going to be your answer. Okay, so this is a software based demonstration of these 3 functions that were present to us previously, right? Y is equals to 10n, n over here I have to take as x, because I have to actually, the software recognizes x only, not n, right? So 10x, y is equals to x log n, y is equals to square root of x, right? These are the y is equals to x raised to power of square root of x, right? So these 3 expressions are present over here. We can directly use software to identify which one, the order in which they grow, right? As when x is increasing, right, x goes on increasing when we go in this direction, right? So as we go on in this direction, which one of these functions is tending to increase the most? Well, the first function is this one increases the most. After that there is this one, and after that there is this one, right? These are the rate at which they are increasing, right? So whatever this function is, it is going to come at the first over here, that is going to be less than whatever the function is representing here is going to come over here, and we're going to come like this, and then the last one is going to come from here, and that is going to come over here like this, right? So this is kind of the basic dynamic of the whole thing. Now let's see which one is the first one. So this one reflects, as when I pressed on this one became a little bit bolder. I do hope that you are able to see that in the recorded video. Increase the resolution, you would be able to see. Now it is selecting this one, now it is selecting this one, right? So the lowest one is this one. This function is y is equals to x raised to the power of log n, right? So y is equals to x raised to the power of log n is the least growing function, right? So x log n is least growing. After that, which function? Which one is this function? Let's see. This one is the first one. This one is the middle one, right? So after that, x raised to the power of square root of x, okay, and the first one is the highest growing function, okay, and that is 10 raised to the power of x. So this is kind of the expression that we get. Let me take a small screenshot of this. Apply this over here. What is happening? So right. So this, okay, I get what is happening. So if I were to apply this over here, oh no man, why it's so complex every time, right? So this x log n, that is n log n, f2 is the least growing function, that is this one. Okay, it validates our answer, right? X raised power root of x, that is this one, is greater than that is this one. Okay, and the x raised power of x, that is this one, is the greatest magnitude of all. So D is indeed the answer. Another form of validation for the same question, because I have more time with the question than you do now. So this is another validation, so that you have more confidence in the analysis that you do, right? I do hope that this helps.